Hi, in this lecture we are going to talk about graph theory, the basic principles behind graph algorithms. So let's get started. Basically, what are graphs? Graphs, and we usually denote it with G, V, E, where V denotes the number of vertices, E denotes the number of edges in that given graph, are mathematical structures to model pairwise relations between given objects. So a graph is made up of vertices or nodes and edges. And there are two types of graphs. A graph can be directed or undirected. Okay, so for example, this is a directed graph. As you can see, we have the vertices or the nodes, vertex A, vertex B, vertex C, vertex D and vertex E. And as you can see, there are several connections between the given nodes or vertices. And as you can see, these connections are directed. We have a directed edge pointing from node A to node B. We have a directed edge pointing from node E to node C and in the direction of node B as well. So that's why as far as directed graphs are concerned, there are directed edges. What about undirected graphs? As you can see, there are vertices as well as edges again, but in this case, the edges do not have any directions. As you can see, there is an undirected edge between node A and node B. Okay, there is an undirected edge between node A and node C, between node A and node D, and so on. So this is the main difference between directed graphs and undirected graphs. Okay, usually we have to handle directed graphs, so we are going to focus on directed graphs as far as the concrete implementations are concerned. Okay, so far we know what is a graph. So a graph is going to contain several vertices and several edges. But first of all, how to model them in programming languages? We have two options, with adjacency matrices and with edge list representation. What about adjacency matrices? We have to construct an A matrix out of the edges and the vertices of the given graph. And the given Aij, what does it mean? We have a row index I and column index j in the given matrix. That given value in the matrix is 1 if there is a connection between node I and node j, and otherwise there is a 0. So for example, this given graph can be represented with this adjacency matrix. We are going to have the rows, we are going to have the columns, and the first row in this given matrix is going to represent what's the connection between the node A and all the other vertices in that given graph. As you can see, there is no connection between node A with itself. It is not a recurrent graph, so that's why there is a 0. But there is a connection between node A and node B. As you can see, there's a connection. That's why there is a 1 in the adjacency matrix. Then again, there's a connection between A and C, so that's why there's a 1 in the adjacency matrix. There's a connection between A and D, so that's why there's a 1. And there is no direct connection between A and E, so that's why there's a 0. As you can see, we are able to get from A to E, but not directly, so that's why there's a 0. It doesn't matter that we can go from A to D and D to E. There is no direct connection between the two nodes, that's why there's a 0. And again for node B. Node B is connected to node A exclusively, so that's why there's a 1 and all the other values are going to be zeros. Usually the diagonal values are equals to 0 because the graph nodes are not connected to themselves. Okay, what about edge list representation? Edge list representation is a different approach. We create a vertex class in Java or Python or whatever programming language we prefer, and it stores the neighbors accordingly. We have a vertex. Every single vertex, as you can see, has a vertex name A, B, C, D and E. we have to track whether we have already visited that given node or vertex or not, so that's why we are going to have a Boolean flag assigned to every single node in the graph to be able to track whether we have visited the node B or not, for example, or node C, node E, and so on. And as you can see, we will have a one-dimensional array or a list that's going to store neighbors of that given vertex. For example, for vertex A, this neighbors list or one-dimensional array is going to store B, C, and D. What about node E? Node E vertex object is going to store just a single neighbor, D. What about C? C is going to contain two items in the neighbor's one-dimensional array, A and D. So basically, we have two options, whether we use adjacency matrices or edge list representation. During the implementation, we are going to use edge list representation because as far as programming is concerned, it's much straightforward to use objects, and we are going to assign a given object to every single node in the given graph. Okay, and of course a good question, why is it important to learn about graphs and graph algorithms? Because there are lots of applications such as the shortest path algorithm. If we want to get from a given place to another, we usually use Google Maps and GPS, so that's why it's very important to find the shortest path between given objects. Then high frequency trading relies heavily on shortest path algorithms. Then we can make graph traversing, breadth first search and depth first search. These are very important algorithms for web crawlers. Of course, Google relies heavily on web crawling. Then we are able to make spanning trees, calculate the maximum flow. Lots of problems can be reduced to maximum flow, so it is a crucial problem. And because there are two representations for graphs, we can handle these problems with matrices as well. This is what we have been discussing, that usually we use edge list representation, but we can use adjacency matrices. And that's why most of Google's algorithms have something to do with matrix related operations, although they are graph algorithms. If you are familiar with PageRank algorithm, it is a graph algorithm, but we are able to handle graphs with the help of adjacency matrices, and that's why we are able to handle this given PageRank problem with the help of matrix-related operations such as singular value decomposition, eigenvalues, eigenvectors, and so on. So this is why, because we have two ways how to represent graphs, we have several approaches how to solve these given problems. So that's all about graph theory. Thanks for watching.